Hello, everyone, and welcome to the NFDI Talks. I'm Elena, and I'm working in the NFDI Association's head office. In our NFDI Talks, every 2 weeks, scientists from different disciplines present exciting topics around research data infrastructure and management. All our talks are live streamed and saved on our YouTube channel. Exclusively in Zoom, we invite you to discuss the topics and ask your questions after the presentation. So, in this episode, we will take a closer look into the NFDI consortium NFDI for Health. In times of strict data protection and sensitive information, combining and analyzing data from different sources can be challenging. Federated data analysis helps to overcome these challenges by allowing us to perform statistical analysis without moving the data. In this talk, we will learn how this can work in practice and explore DataSHIELD, a federated analysis framework in the NFDI for Health consortium to securely analyze health data from multiple cohorts across various institutions. Today's speakers are Florian Schwarz and Sofia Maria Siampani. Florian is a data scientist at the German Institute of Human Nutrition in Potsdam-Rehbrücke, working primarily on extending the capabilities of the distributed data analysis platform DataSHIELD. He holds a PhD in geography from Northumbria University, Newcastle, and joined the NFDI for Health consortium in January 2021. Sofia is a programmer at the Max Delbrück Center Berlin with a focus on federated data analysis infrastructure, contributing to the NFDI for Health consortium over the last 4 years. She holds a master's in bioinformatics from the University of Glasgow. Now, welcome Florian and Sofia. We're looking forward to your presentation.
Yeah, thank you, Elena. Okay, yeah, welcome everyone to our NFDI talk on DataSHIELD. I will guide you a bit through the background in the beginning of how DataSHIELD is embedded in the NFDI for Health consortium, tell you a bit about the concepts, and then later on, Sofia will give you an overview into the practical aspects on how it looks in reality. So, DataSHIELD in NFDI for Health is important because we are actually dealing with personal health data that will guide us throughout this talk. But more overall, NFDI for Health, as many of you probably know, is part of the life sciences in the overall NFDI scheme. And our mission in NFDI for Health is actually to increase the value of research data from epidemiology, public health, and clinical trial-based studies. And in general, we are guided by the FAIR principles. I think also many of you have heard already, so making data findable, accessible, interoperable, and reusable. And with the analysis part, of course, we are more on the reusable part of the FAIR criteria. So in Germany, what makes up the NFDI for Health community? So we have a lot of studies that have cohort data, in the various different parts that I already mentioned previously. And what we really want to do is actually leverage this cohort data for research projects that we have defined. So in order to do this, this goes back a bit to the FAIR principles as well. In NFDI for Health, we develop key infrastructure elements, such as the local data hub, so where institutes can have metadata available internally in their own institute, but they can also then choose to make this findable for everyone and have it in our search portal, the Health Study Hub, which can then subsequently be applied for using the FDBG. This is an infrastructure that has been developed in the Medics Informatics Initiative, but we in NFDI for Health also want to use that in order to really coordinate the application processes to the data holding organizations. And then when it comes down to doing data analysis, this is what we are talking about today. We are talking about the federated data analysis nodes that are part of the institutes. And also we have an infrastructure that is centrally managed at the MDC. So we also don't want to obviously only do that build up of infrastructure just for itself, but we want to use it really for research purposes. And that's why we have also drawn up some pilot projects that are used for implementation and testing of these central and local services, including the federated data analysis framework. But the ultimate goal, obviously, is to reuse the research data, because in general, it also leads to more comprehensive insights when we are combining not only our own data, but also use data from different sources. And I think across the NFDI consortia, I guess this is a shared objective for all our disciplines. Now, in NFDI for Health, we also have some challenges in doing that. So if you remember the map that I've just shown you previously, you see all of these various different institutes that hold data. They have conducted their cohorts using different questionnaires, assessment instruments. Maybe they have collected the data in a varying level of detail. So what I want to say is that the data that is available is very heterogeneous in terms of format, quality, definitions, etc. So what is very important prior to data analysis is actually that we need some form of standardization and post-hoc harmonization based on the available metadata, so that when we do the distributed data analysis, that all the variables have the same meaning in the end. And in NFDI for Health, we use the harmonized package that has been developed by Maelstrom Research for that. But I don't want to go into more detail on this part, because there will be like a whole different topic that we are not having today. Yeah, and for the use cases, we are focusing in two things: on nutritional epidemiology that is led by a colleague of mine here at the DIFE, and epidemiology of chronic diseases, which is led by someone at the MDC and the University of Bonn. Now, a bit of background, because I'm not sure if everyone is really fully aware of what federated analysis is and what centralized data analysis is, or to see the challenges also in combination with what type of data we hold in our consortium, is that usually in centralized data analysis, what is being done is that the data holding organizations have some data use agreement signed together with the analyst, and then send out the individual level data. And then the analyst does the coding, the data processing, also then gathering the aggregated results, while having the compiled version of all this data from the different institutes. Now, this, of course, has some advantages. Yeah, so the analyst has full access to the raw data. They can be quite flexible in their analysis, whether that's they want to do analysis using SPSS, SAS, R, Python, yeah, you name it. So they are really flexible. And also for the institutes, they would not need to build up additional infrastructure. However, of course, there are also disadvantages related to centralized data analysis. And this goes specifically to our consortium, where in most cohort data, research questions relate towards diseases, whether that's cancer, diabetes, all types of personal information that we really have here. And when the GDPR, so the General Data Protection Regulation law, has been set up on the EU, it defines this type of data highly sensitive. And so the institutes actually have to make really sure that this data is being safeguarded. And while sending out these individual level data to an analyst is really not the way to go here for us in NFDI for Health, because we have all of these challenges governance-wise or with the ethical legal challenges. On the other hand, federated data analysis, what is happening here is most likely we also still have data use agreements, specifically when it comes down to providing credentials to analysts, etc. But in general, the individual level data stays at the institutes, and the analyst actually sends code to these institutes. If you've ever heard of the term bringing the code to the data, this is what is usually being referred to. And then the data processing happens at the institutes, and they send then back the aggregated results separately, and the analysts can then combine that on their own. This has the advantage that no data transfer is necessary from the data holding organizations, and that they are keeping the full control over how it's being processed. So here it's just like a very generalized figure or sketch. So it could also be a bit differently in the setup of the architecture. Yeah, there are other federated data analysis frameworks such as Personal Health Chain or others, but this is generally how it looks like. On the downside, to do this, in most cases, additional infrastructure is necessary. In our case, it's DataSHIELD, what you will see then on the next slide. But also the analysts are then, of course, a bit less flexible in their analysis, depending on what infrastructure has been set up at the institutes. And another point that I put on both the advantage and the disadvantage is that analysts cannot see the individual level data. From a data protection standpoint, of course, the institutes really need to have that, but analysts are typically a bit more wary and feel less comfortable if they can't see how the actual data looks like, although it would make no difference in their analysis. Now, when it comes down to the DataSHIELD architecture that we have set up now then in NFDI for Health, what is happening is that an analyst will log into the central R server at the MDC, where DataSHIELD client packages are. This will be important in a minute. And then from there on, they can connect to all the different DataSHIELD servers where they have gotten credentials for their research projects. And just to briefly give you an overview of what the main components, so to speak, are all of these server sites, is that, of course, there's some sort of data storage. Then there's an R environment on the server sites. And importantly, there's also something that is called an Opal server. This is a server application where the institutes can manage their settings, whether that's credentials for analysts, so like the identification process, whether that's the server-side packages of DataSHIELD, because there's not only one, but there are multiple. They can also manage this here, disclosure control that we will talk about later, etc. So like they have a lot of management opportunities over here to tailor their own system really on how they want to have that. And the analyst would then always send a request to the server and then interactively gets the results. Now, a central server is not really necessary per se for DataSHIELD analysis, but why we opted to do or to set up such a central infrastructure in NFDI for Health has multiple reasons. One, we are better at harmonizing the process of data analysis, and also this provides institutes with an option to only whitelist the central server here at the MDC for incoming requests. What that means is that analysts could never even send a request to the different types of servers who have implemented this IP whitelisting. So it basically adds another layer of security for the institutes that analysts have to go through another step of logging in and proving their identity. And for all of these installations. Sofia and I are guiding the institutes through their process, and we have also compiled a list or like an SOP for the installation and configuration of these systems. Now, how does the client and the server side interact with each other? I already mentioned that we have complementary packages, so a client package and a server package that interact with each other. And what is happening is that if, for example, I want to execute a function that retrieves the quantiles and the mean of a variable, I'll just execute this function on the server. And this then forwards the code request to the server side. And this happens basically because in the client side, we have a function call for the DataSHIELD interface that actually then executes this function. And on the server side, this is where the real, so to speak, mathematical operations are happening. So whether that is to do some log analysis or like a transformation, log transformation of a variable, to build the models, etc. All of this is happening only on the server side. And once the function has been executed, at the end, there's a disclosure check. And if that passes, then the analyst would receive the aggregated output. However, if that will not pass, or if that doesn't pass, then the analyst actually would receive an error message explaining why they could not retrieve the results. In most cases, it's because, for example, too few data points, so maybe only one or two, were able to be used in a certain function, and that could potentially be then leaking individual level data that we do not want. So for the pilot project in NFDI for Health, and this is like a map now only showing the institutes who actively want to participate in those pilot projects. We are in contact with them in the installation or the rollout of DataSHIELD, and I think most of them are already done. Now, why have we actually chosen DataSHIELD if there are also other options for federated analysis? Well, one point is that it is already an established distributed data analysis platform. So I think the white paper and the concept are going back to 2009, so a long time before already the GDPR came into effect in Europe. It is open source, so the functionality packages, they're all available on GitHub. So I can have a look into that. Institutes can have a look into that to see if what they are installing, if they want to do that, is really fitting what they want to have on their systems or not. So they could decide against it. Then there's an active community and support also in DataSHIELD. Not to be underestimated, institutes from our consortium have already previous positive experience in done projects and ongoing projects. But I think the most important one is that DataSHIELD allows us to have an interactive request response workflow with an automated disclosure check. And what I mean with the interactiveness of the request response is that there's no human, so to speak, in the middle who would have to do something. So, for example, you could have also have a federated data analysis framework where basically you are writing scripts and then sending it to someone at an institute who would then check it, execute it, and have a look at the output again, and then sends the results back, which can be quite labor intense. But here in DataSHIELD, everything is happening interactively, and also the check on whether the output is secure. So we are not the only ones actually in NFDI for Health who are using DataSHIELD. So there's a lot of consortia actually who use DataSHIELD or have used DataSHIELD in the past. And we're at the DIFA, at the MDC, also we have been part of the NPADASI consortium, for example, or the Intermix one that is still an ongoing project. And because of the number of consortium or initiatives, you can already guess that actually the participation of studies in DataSHIELD projects is quite large. So yes, it is dominated mainly in Europe and maybe also North America, but actually worldwide studies have participated already in this distributed data analysis framework or for projects. And so also on the publication side, it is gaining momentum now that the rollout and convincing people to take part in such projects has been done in the past. Of course, yeah, the publications can vary a lot. So whether that has to do with environmental impact on health or things related to type 2 diabetes from various different cohorts with different research questions, road traffic noise, and then the risk to maybe cardiovascular diseases, etc., etc. So within the health science, where the primary focus right now is of DataSHIELD, there's a lot of different things that can be done and analyzed. But it's not only the studies who are, of course, participating in DataSHIELD projects, because for something like this, you also need an active team of developers who are constantly looking at functions, creating new ones. If analysts see, okay, they want to do something very specific that has not been implemented yet, and also having a look at that, obviously the results from the DataSHIELD side of view is the same as if data would be stored in a centralized storage. And besides the developers, of course, we also have key infrastructure providers, so that deal with the most important elements in the software stack that we have. So yeah, this is, I think, more or less what I just mentioned, that yes, there's a continuous development of functions in the various packages that can be used to do DataSHIELD analysis. There are ongoing developments in these more infrastructure-like software components, and also in other areas. We are actively working on how to write guidelines for safe operations, to distribute that to the different consortia, etc. What are, like, so to speak, best practices, etc. And with that, I would like to hand over to my colleague Sofia, who will then now talk more about the practical aspects and show in the demonstration as well how it really looks like in reality, what DataSHIELD is.
All right, yeah. So Florian mentioned earlier the OPAL servers, and the OPAL servers are web applications that enable the data holding organizations to manage their projects, their data, and also user permissions. So now we're going to see a very simplified version of the workflow that the data holding organization would follow to enable analysis for the analyst. So the first step usually involves to create a project where the data holding organization can then upload the data dictionary into the project and import individual level data attached to the data dictionary. Then the data holding organization can create the credentials for the analyst and then assign permissions to use DataSHIELD and also view table dictionary and summaries for the respective table. Now, the analyst can then use these credentials to connect to the study and perform federated analysis. Also, through the OPAL web administrative interface, there are certain control options for the data holding organizations that they are configurable so that they can match the project needs or the analyst needs. We're gonna see some examples here. So we have the tab filter, which is the minimum number of data points required for aggregate function. And there is GLM1, that you can define the ratio for parameters to number of data points in modeling functions. There is a filter for noise, that is for the addition of noise to variables in certain functions, and this is usually relevant for graphs. And we have also a filter for KNN, that is the number of K nearest neighbors of each data point for transformation in graphs. And now we're going to move into a short demonstration. In the demonstration, we will use mock data that were inspired by 2 studies. So we have EPIC Potsdam that is hosted at DIFE, at the DIFE Opal server, and Active that is hosted at the MDC Opal server. And both studies contain the same 8 variables that were harmonized before their upload. And for that, I'm using the central R server at MDC. This is the login page. I'm gonna use my credentials to log in. Okay. And I have already created a session for us, and the script is preloaded. And the first step is usually to install the DataSHIELD packages. This is already done. So I'm just gonna go ahead and load the necessary libraries. And after that, we wanna log into the 2 Opal servers. So here I'm creating a builder object where I am storing the credentials for Active and for EPIC. I'm retrieving this from my environment where I have stored them. And after that, I can do DataSHIELD login. This function allows me to assign the data, and I'm doing it in D, which is the data frame that is stored in the 2 server sides. All right, and now I have logged in. Now with DataSHIELD, there is a lot of functions that we could show you, but we just decided to show a subset of functions that you can use due to time constraints. So we can start first with just ensuring, like just having a look which variables we have out there. So here we can see that in Active and in EPIC, we have those variables that I showed you earlier. And we can do DS class to get the class of specific variables. In that case, sodium-potassium ratio is numeric in both instances. But if we want further information, we can request the metadata. And here we can also get some more information. Now we have the label, and we can see that it's the participant status regarding cigarette, never smoker, former smoker, current smoker. With certain DataSHIELD functions, you also have the possibility to show different displays upon execution, depending whether you want to show the combined one or the split one, or both. So, for example, for the dimensions here, we can see the split dimensions for the 2 studies, but we can also see them combined or both. And also, as another example is to be able to retrieve the number of NAs. And in this case, we have 38 NAs in the active dataset. All right, so now we are going to move to transformations. We are performing transformations on the individual level data, and this happens on the server side. This is very important because we never see the individual level data. Therefore, if I were to assign this in a variable in my environment, as I'm going to run it now, you will see that it's actually null, because this is an object that is created on the server side. And this is how I get the absolute value of sodium-potassium ratio, or like if there were negative values on that example. Then we can do the log transformation. We can also do complete cases for the whole data set where the rows with NAs are removed. And now I'm going to call ds.ls, and this will show us all of the objects that they have been created on the server side. So we can see the original data frame, we can see the clean one without the NAs, and we can see the transformations that we did earlier. Then we can do some aggregate functions. So we can do the DS main, and here I'm assigning again to a variable on the client side. So in this instance, because it's an aggregated result, we are able to see the output and store it here. We can also do mean and standard deviation per group. So in this scenario, we're doing the age baseline per smoking status. We can do correlation. And we can also do summary for continuous variables, where we get the quantiles and mean. And we can also do for categorical variables as well, where we get the counts. Then we are gonna build a model. So now we're gonna feed a generalized linear model. In this case, we have B minus the outcome and vegetables and age at baseline as the covariates. And this is the output. Now, as Florian mentioned earlier, the output is mathematically equivalent as if we were to pull the data from the different sources in one central repository and do a GLM this way. And for that, we want to show you how it would look like in practice. That's why we have loaded the mock data that we're using, and we're combining it, and we're using the base function of GLM to perform a GLM. And now we can compare the centralized one and the DataSHIELD one. And this way we can see that it is indeed mathematically equivalent. With DataSHIELD, we can also do some graphs. And I have here, for example, BMI, where we can see both a split view of the studies, and we can also have the histogram of the pooled data. Lastly, due to the analyst requests, we developed this package called DSupport Client. And DSupport Client essentially wraps around already existing DataSHIELD functions. And it helps a lot with the time and the output that the analyst gets. So in this example, we are wrapping around DS class. And instead of doing it, doing separate function calls for every variable, we can have a combined one. Study. Yeah. This is important because in certain cases, whenever you want to perform a function to using the variable across sources, you might have an error if it's not the same class, and this has happened in the past. So running this maybe in the beginning of the analysis can help you identify if there are any mistakes in the data set, and you can correct that before going ahead. And this is a similar function that is for performing DS summary for numeric variables. And here we can see the quantiles and mean and standard deviation. Last but not least, we have to log out of the session. And that is the demonstration parts. I'm going to now move back to the presentation. Okay. So yeah, in NFDI for Health, we strive to support both the data holding organizations by providing SOPs and also troubleshooting support. And we also want to help the research analysts. So we offer the analysis environment that I just used. We also offer starter R scripts that can support the analyst in the initial stages of the analysis. And of course, if there are any on-demand functions to enhance the analysis capabilities, and also troubleshooting support. Florian and I have also been developing certain packages. So we have two packages, this cluster analyses in this intestinal microbiomics, that they are client-server packages that they have been previously used in projects and will be used in future projects as well. And we're also developing some packages that they are for improving the user experience. And that is the DA support client I just showed and this function creator. And now looking ahead for the second funding phase, some goals that we have is perhaps getting some sort of DataSHIELD certification or have an approved code of conduct. This will hopefully encourage the data holding organizations that they might still be hesitant in installing DataSHIELD on going ahead and doing it. We also want to refine the cost models that we already have to increase the sustainability of the decentral and central components. By decentral components, I mean the OPAL servers. We want to make sure that the OPAL servers of every institute can be sustained beyond a funding period and can be used in future projects as well. And the central component is the central R server, where we want to make sure any operational costs or licensing costs can be covered through this model. Also, we want to widen the adoption of DataSHIELD by increasing the usability for non-R users. We have noticed that a lot of our analysts have more of an experience with SAS. So for that, we want to build an online tool for providing ready-to-use modularized R code chunks, also functions to accommodate typical research questions, research analysis requests, and optimize the output, and also missing client server-side functionality. Of course, it's also to our best interest to be aligned and collaborate with other NFDIs, German and European initiatives. And of course, there is already significant collaboration between NFDI for Health and other NFDIs. In terms of DataSHIELD and to support its optimization and consolidation, we are planning some research projects targeting on the health to disease transition. So there is a project with GHGA involving the standardization and federated analysis of genomics and other biomarker data across several epidemiological studies. And there is another project that is supported by NFDI for microbiota. And this project is for implementing a bioinformatics pipeline to reach a higher degree of standardization of gut microbiota data across epidemiological studies in Germany. And another thing that we would like to achieve is integrate the NFDI AI that is developed by the base services for NFDI that also ensures compatibility with EOSC AI. Also, in terms of European efforts, we would like to establish the DataSHIELD servers as secure processing environments as they are defined by the European Health Data Space. And we want to make the central analysis server discoverable in the European Open Science Cloud EU node services. And with that, I want to thank you for your attention.
Thank you very much, Florian and Sofia, for your presentation and this interesting insights into your work and DataSHIELD. Yeah, with that, it's the moment to say